All right, people, we are into chapter 4, and we're going to be in section 4.1 here to start it off. And this is graphing equations in slope-intercept form. Okay, so an important section here, and we're excited about it. Chapter 3 was a lot of writing equations and putting them in certain forms and rewriting equations and things like that. Now we're going to actually graph them based on them being written in slope-intercept form. So the first thing we're going to do is we should know what slope-intercept form is. Some of you guys have started to figure this out as we go, and we kind of talked about it a little bit in chapter 3, but y equals mx plus b is your slope-intercept form. And m represents your slope, and your b is your y-intercept. And I don't know if we've used b all the time for it. We kind of touched on it in a couple sections, but that's your y-intercept. And I think you'll find this to be pretty simple once we get into this form. The big thing we have to recognize here is we've got an m and a b. And those are important to know that we're going to have to substitute in values for m and b. The y and the x are going to stay there the same. We're going to substitute values in for m and b, your slope and your y-intercept. So down at the bottom here with these practice problems, pretty simple one in part A, slope of 3 and a y-intercept of 5. So basically we're just going to substitute these in. This would be my m, and this is my b. So I could simply just write this one, y equals 3x plus 5, because 3 is my slope and 5 is my y-intercept. Then we go over to letter B here. Same thing. I've got a slope of 8, and I've got a y-intercept of -3. Here they just list them in 8, and there's m and b. So in this case, it would be y equals 8x, and the slope and the y-intercept is -3, so it would be 8x minus 3. Simple as that. Just got to know you've got an m and you've got a b. M's and b's. That's what you got to figure out. That's the key to this lesson. Okay. So moving on. Well, we want to write an equation given a graph. So they're going to give you a graph, and we're going to have to write an equation based on that. A couple things we have to do. First things first, we have to determine the slope. That's number one. And you've got a variety of ways in which you can do that. I'm going to list 2 of them here. One way, if you've got 2 points, 2 coordinate points, then we can use the slope formula. y2 minus y1 over x2 minus x1. That's an easy way to find the slope. Or if they give you a graph, you could just count. Use the rise over run. Remember, rise is your up and down. Your run is your left and right. And so those are 2 easy ways. You could go change in y over change in x. You could make a table and find the change in y and change in x and find the slope. But no matter what, you've got to determine the slope. The next thing, and remember, slope is our m. That's our m value. Okay. The next thing we have to do is find the y-intercept. It's slope-intercept form. So slope, and now the second part would be the y-intercept. This is your b. This is your b value. Okay, so that's your b value. And the easiest way to do this one is to look on the y-axis. Look on the y-axis. Because, remember, your y-intercept is where the graph touches the y-axis, where it crosses the y-axis or where it touches the y-axis. So if you're given a graph, you can easily find the y-intercept by looking at where that graph, where that line touches the y-axis. And then the third thing you're going to have to do is use those m's and b's and plug them into the equation. So once you find your m, once you find your b, plug them into the equation, and you're good to go. Y equals mx plus b. So let's do a practice problem. Let's just do number 3 here. We'll just do number 3 here. We can work on 2 and 4 later on. All right, so number 3. We've got rise over run, or excuse me, we've got a line here. We've got 2 points. So how do we want to do this? Now, we got 2 coordinate points. If I see that, then I'm going to kind of use the slope formula if I've only given the coordinate points. But because I'm on a graph, I'm going to count rise over run. I just think that if I've got the graph in front of me, it's easier for me to count rise over run than it is to use the coordinate points. If they just gave me points, well, then I'm going to use the slope formula, obviously, because I don't have a graph to go off of, which that may be the case sometimes. But here we have a graph. So I'm going to go out rise over run and try to get my slope. So I'm going to rise over run here. If I start from this point here, I'm going to go rise first. I'm going to go down 1, down 2, down 3. So I had to go down 3. And then I have to go over 1, 2, 3 as well. So my rise was, if I go with my slope rise over run, my rise was -3, and my run was 3. It was a +3. So my slope was -3 over 3, which is equal to -1 when we reduce it. And then our b value for my y-intercept, basically what I want to do here is I've got to look at where it touches the y-axis. And here it is, right here. It touches it at +3. So my b value then would be 3. So since I have an m and a b, I'm ready to go. Now we can put it in slope-intercept form. So I can go y equals, my slope is -1, so it'd be negative, I don't have to write that 1, so -x plus 3. And that would be it. Okay. Next up, let's look at graphing an equation using slope-intercept form. So now they're going to give us the equation, and we're going to graph it, just the backwards of what we just did. We're going to take the graph, we're going to take the equation, graph it. So the first thing we're going to do is we're going to put the equation in slope form if needed. If it's already in slope-intercept form, then we don't need to do anything. But remember, we want to get it in slope-intercept form. So the idea is we want to get it in this form, y equals mx plus b. So if it's already in that form, then we don't have to do step 1. But if it's not, then we have to rework it to get it in that form. So let's say we had an example where it was, say, like 2x plus y equals 7, like in standard form here. We want to get it into slope-intercept form. So in order to do that, I'm going to have to solve for a variable. In this case, I'm going to solve for y. And so what would we do? The easiest way to do it would be, well, let's subtract 2x from each side. If we subtract 2x from each side, then I could easily rewrite it because I would isolate my y value, and I'd have, y equals, I'd have a -2x and then plus 7. And it's important to kind of note here that I write my x values first, and then the number, then the y-intercept, just so it can match up in slope-intercept form. And if we just take this over here, you can see how it matches up pretty nice. Y equals -2x plus 7. Kind of nice and neat in slope-intercept form. So I always put my x value first on the right side of the equal sign, and then the number. So we're in good shape there. So that would be one thing we could do. If we need to do it, then we can do that. If we don't, if it's already in slope-intercept form, don't worry about it. But if you need to do it, then we're in good shape to do it there. Now, place the y-intercept, your b value, on the y-axis. So that means we're just going to begin with b. So think about that. We're going to begin with b. Starts with b. That's where we're going to start our graph. Put the y-intercept on there. We know it crosses there, and we're good to go. And then we're going to use the slope formula, or excuse me, use the slope to move vertically and horizontally. We're going to use rise over run. We're going to vertically first, then horizontally, whatever our slope is, and kind of get a couple points. And we want to plot at least 3 points and then connect the dots and get some arrows. Okay? So let's do some examples of this as well. So first thing we're going to do here is we're going to graph each equation on a coordinate plane. So let's start with, let's do 5 and 6. And we can do number 7 at a different time. Or if you feel good about it, we'll see how we're at. So we've got a situation here where we're already in y equals mx plus b form, right? Y equals mx plus b. That's what we want to be in. In this case, we're already there. Y equals -2/3 x plus 1. So again, just get in the habit of listing your slope and your y-intercept. Okay? Our slope we know, our y-intercept we know is 1. It's right there, b. And our slope here we can list is -2/3. Okay? The other thing I want you to point out is notice how I wrote the -2/3 there, the -2 above the +3. And that just helps me when I do my rise over run. It just kind of helps to plot those points. So the next step was to place the y-intercept on the graph. So we know the graph is 1, so y-intercept would be at 1 here. So that's 1. That's 1 point. And now I'm going to use my slope, my rise over run, to get a couple more points. So I'm going to go down 2 and over 3. Then I'm going to go down 2 and over 3. Okay, and I've got 3 points. I can also go up 2 and left 3 to get another point there if I run out of room going to the right. But here I have enough points to draw a graph. The other thing I'm going to say is to when you graph, go way past your points. Don't just draw them like right to the edge and stop. Keep going, extend them so we have a nice line there, and draw arrows at the end. Simple as that. And then you're done. That's it. All right, let's look at number 6. On number 6, you've got a y equals 1. Well, there's no x there. So there's no problem. We can still graph this even if there's no x. Just remember that in this case, we've got, if we were to write it in slope-intercept form, well, there's no x. So that meant our slope must have been 0. So it would be 0x plus 1 if we were trying to graph it. So in that case, our slope is 0, and our b value is still a 1. We still have our 1 there if we put it in slope-intercept form. Okay? So I can place my graph on the y-axis. I still have a y-intercept, so I can place that point there. B is 1. And now I've got a slope of 0. Well, that means it's going to rise over run. Okay? Well, I have no slope there. So I'm going to rise 0. I'm going to run. I'm going to rise 0. I'm going to run. Because it'd be 0 over something, right? So I've got nothing to do there. So I've just basically, all these points, you can see it's going to be a horizontal line. And if you remember, our graph, anytime it's just y equals something, it's a horizontal line through what it equals. So in this case, y equals 1. It's a horizontal line through 1. Simple as that. Okay, let's do one more, and let's do number 9 over here, because this is one of those ones where we're going to have to rearrange and do actually step 1 and rearrange it into slope-intercept form. Notice this one is not in slope-intercept form. X minus 2y equals 6 is not in slope-intercept form. So we want to get it in this form, but it's not there yet. So we're going to have to do some work. Remember, we want to get y by itself on the left. So the easiest way here is to first subtract our x. Get rid of this x. And so now when I rewrite it, I've got negative 2y equals, and I'm going to write my x first, negative x plus 6, just so it's closer to be in slope-intercept form. Now my y is still not isolated. It's still at a negative 2y, so I got to get rid of that negative 2. So I'm going to ask people, you say, oh, what do we do to that negative 2? Well, a lot of people are going to say add 2. But what's happening to the y? Well, there's no sign in here, so that means multiply. So the opposite of multiply is to divide by negative 2. And then I'd have to divide over on the right side each of these by negative 2. Okay, so let's just work from left to right here. We can see that on the y's, negative 2 divided by negative 2 is going to isolate that y. So it's going to be y equals. And now you've got an interesting situation where you've got a negative x over negative 2. Well, negative over negative is going to make that a positive x over 2. And basically, that's the same thing. Remember, I could put a 1 in here. And so I could rewrite that as 1 half x, or 1 over 2x. And I can bring that x just to the side. That makes it a little bit easier to understand slope and y-intercept. And it kind of gives you a little slope here. It gives me a rise over run look. So here I can see that my slope is going to be 1 half. My b value is going to be, well, let's rewrite the equation first so we can get our b value. So now I've got y equals 1 half x. Change colors there. And then my y value here, 6 divided by negative 2, I'm just doing the math there, that's going to be negative 3. So I've got a slope of 1 half and a b value, a y-intercept of negative 3. So when I go to graph this one, I'm basically going to look first, place the y-intercept on here at negative 3. And now I'm going to go up with my slope and rise over run. I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. I should be in good shape here. Sorry about that. So now I've got my y-intercept. I can start at negative 3, and then I'm going up 1 to the right 2, up 1 to the right 2. And when I do that, I get enough and where I can simply draw my graph. I've got enough points plotted where I can go that way. And again, remember, if I run out of room to the right, I can always go down 1 and to the left 2. But that's a little bit trickier one because you have to actually rework the equation first. And just remember that this 1x over 2 can be written as 1/2 x. And for the y-intercept, I just did the math. 6 divided by -2 is -3. Okay? So that just about does it. And let's move over here to our lesson summary. That brings us there. So the first part here is, what is the slope-intercept formula? And what does M stand for? What does B stand for? We should be easily able to decipher those. And then over here, explain how to graph the equation. We're not going to graph it. I just want you to explain to me in your own words how you would graph the equation. Okay? Then we'll do some practice on this. And if you have any questions, let's go over them. All right.